Okay, some of the common documentation problems. Now, optimal implementation. So this is getting here. I've had companies where I come in and they have a team of 40 engineers and the descriptions are just fantastic and they get assessments filed every year. And so I started asking myself, how do these guys do it? How do they coordinate everyone to get all this information so easily when I'm dealing with 2 or 3 people here and I can't get it together no matter what, right? The common themes are they try to get everyone informed as early as possible. So in that design meeting or whatever, they talk about what's our standard practice, what do we do, what's our due diligence, and what variables do we think are the problems. That's the common theme I've seen with them. Well, and they'll say, well, we got to test this, this, and this. We recommend the following test plan, and that will outline the things that they're going to change, the things that they're going to do differently. And get the team to agree what's the most important, because we want to focus on the high-level stuff. On a $1 million project, we don't have time to explain everything. We've got basically 100 lines of text where we got to explain the most important stuff and hope that that explains enough of it that the reviewer can say, oh, well, the rest of it is intuitively easy to follow. Okay? So this, by ranking the variables of uncertainty, I found that this is the method that these companies use in order to provide conciseness and brevity, which the Canada Revenue Agency says is both in the interest of the claimant and the agency itself. They don't want a 100-page PhD thesis. They want the 1-page executive summary of what's in that, and that you keep that 100-page thesis for review if they want to come out and review you. Okay? So the most common documentation problems, and I'll use these shapes to look at it. This one always starts the same way. And until you do a lot of SR&ED claims, you think it's actually a good thing. They say, this product is the first of its kind in the world. Right? You say, oh, okay, that's great. There's nothing like it. When I see that, I'll send them and that's the first line, and I think, oh, this is going to be a problem right away. Because inherently, when people say that, often what happens is they say, well, because there's nothing similar, or there's nothing exactly like it, there's nothing similar. Okay? So there's no method to do anything remotely close to what we're doing. That's usually not the case. Usually, we're improving on something that someone did. It could be a huge improvement, or it could be an infinitesimally small. It doesn't really matter. But there's something close. Maybe it was a different industry. Maybe I'm taking it from an environment that's slightly different. So that's perfect. Where did we see the most similar method, or a potentially plausible method as a starting point, and how is it different? Okay?
So you're voting on an innovative transfer.
Exactly. So they say to do systematic investigation by qualified personnel, they have to have done their due diligence, right? And more, the claims that are losing when we look at them have pretty good systematic investigation. They've kept notes. They've got they've got all of it. The judge came back and said you didn't benchmark standard practice. So everything else is irrelevant because you have no foundation. I call it a square. That's your foundation you're building on. If they pull that out, you can have all the hypotheses and experiments you want. You don't have a basis to show you're outside the box. Okay, so first thing, define the box. So these often have very skilled people doing really complicated things, but usually they go to the answer, or they go off and they don't make conclusions that are tied to the standard practice. So either way, they're going to call that random investigation. I put this on the number 2 slide, but it's probably the number 1 reason, and it kind of goes hand in hand with the first slide, for denying claims. And they'll use different terms like routine engineering or standard practice. And basically what they say is that the problem or hypothesis you proposed isn't really a hypothesis for someone skilled in the art, that had they done the proper due diligence, they would have found a solution that they could just plug in or reasonably get to without a requirement for experimentation. Okay? So the way to refute that is, again, to do your due diligence work. How much is reasonable? The more the better, right? And then let the judge decide if you did, because all the access says you have to do a reasonable amount of due diligence. And then they don't say what that is. So again, use your judgment. I call it passing the laugh test. If you can sit there and look the auditor straight in the eye, or the judge, and say, I think, in my professional opinion, I did adequate due diligence here because I don't want to waste the company's money on stuff, they're probably going to take you at face value, right? Unless there's evidence to the contrary. This is actually a sadly common one. Activities beyond someone's qualifications. Usually, that's not disastrous. And I see this a lot on successful claims as well. I remember I had one client who came to me on an objection. It was an obstetrician. This was back in like late 90s, I guess, early 2000s, when the internet was just coming on. We didn't have really fast, high-speed bandwidth like we did now. And what this fellow was doing was he was taking ultrasounds and figuring out if he could fax them, if another doctor could fax them from a remote area. So he was in Toronto, and he said, well, I want to be able to give a diagnosis to an obstetrician in Barrie, let's say, while his patient is still there. So that gave him 1 hour time frame that they had to take the ultrasound, fax it to him. He would interpret it and ask other questions or make an observation so that they could do whatever other test they needed while the patient was still there. They didn't have to do a repeat visit. Because normally they would just mail that, and a week later they'd get it back. And the fax technology was such that they had to compress it. They couldn't send the whole thing within the hour. And they tried 9 different compression methods to see what happened. And basically, most of them failed, but eventually they got it to a point where they were pretty close. The problem is they claim this all as a software advancement. And they sent a software reviewer in and said, you're just using proven software compression algorithms. Like, none of this is an advancement in software. You're just using off-the-shelf products as their intended use. But when I looked at it and really figured out what was happening, the advancement wasn't in software at all. The advancement was in medicine. So when I talked to the obstetrician, I said, well, what are you doing? Like, how do you determine which of these is a valid one or an invalid one? He'd say, well, I look at the color of the vein. I said, what do you mean? These are black and white. He says, no, not color like you would think. Color has a very technical term. It means the density of the vein. And it has a whole bunch of very finite characteristics, measurable, quantifiable characteristics, and a series of other things. I said, well, so you're seeing how we can take an existing standard practice ultrasound, what parts of it we could lose before you make a potentially fatal diagnosis. You misdiagnose something someone's going to die now because of that. Very serious. He said, yeah, that's basically what we're doing. And when we went and looked at his notes, we said, well, this is an advancement in medical science. The reviewer that they replaced with the medical agreed. This was clearly an advancement in medical science. And actually, our claim went up about 500% because the obstetrician didn't include all of his time. He had a very high salary, much more than they were paying the software reviewer. So again, understanding the field of science, the problem is for someone who's skilled in a field, it seems kind of obvious to them. You know? The software, if you ask them, the software was the really complicated part. The stuff he's done for 20 years, that's what he does every day. It didn't seem that complicated. So again, often as advisors, we have to advise the client on the proper scope. The first thing I ask is, what's your training in? And then what field are we trying to make an advancement in? Because we want to make sure there's some kind of match there, not a dichotomy.
So has he gone further to do artificial intelligence to capture it?
You know what? I wouldn't know because that wasn't my client. It was another SR&E consultant, and I just helped them out in a pinch on that. So, you know, I'm more like a troubleshooter, hired gun on that job. Okay, and the last of the 4 most common documentation problems, and you see this a lot, is failure to keep records, okay? Or keeping records but failing to tie them to the variables, or what the government would call hypotheses. So you're doing all kinds of stuff, but they don't see a clear line of attack on it. And I see that all the time. My tool and die guys are the best. The president of the company gets out there, he's been doing tool and die for 30 years, he's like a human computer, probably calculating 20 or 30 variables in his head while he's prototyping stuff on his machines, but they don't keep any records. Okay? So again, are we going to be able to claim that or not? I'll say, hey, Tony, pay some kid to follow you around and ask you why you're doing stuff, and all of it, write it down. We're in. Or get the machine, keep the machine, anything. Keep any kind of evidence that you can of what different variables you tested, and then write a conclusion on it somehow, or have it support your conclusion. We're good. Okay, so just think as you're doing stuff, is there any evidence here that I could keep and not delete or destroy or whatever, right? So capture that real time. Okay. Any other questions about that? I'm going to give an example, and then we'll take a quick break before we jump into the sample descriptions. We're going to look at 4 sample projects. So I always like to talk about, I used to use a video, but I'm going to get rid of that. The difference between scientific uncertainty and system uncertainty. And this is very important, I find, especially for first-time claimants, because most first-time claimants have the wrong idea of what we're looking for. They think it's the end result that's going to evidence the advancement to us. Okay? And I would use the example of Thomas Edison here, who, quote, invented / perfected the phonograph. Right? So this was a pure scientific uncertainty. We're told that at the time he did this, no one had ever recorded sound before. Now, whether that's true or not, the history books could argue it, but he was the first to patent it, so we're going to go with that. Right? And what he did was he had a hypothesis that I'll take this wax tube, I'll put a charcoal filter with a pin, and I'll talk into it, and it'll create vibrations on this tube, and when I play them back, it's going to create sound. It's kind of a funny joke that Thomas Edison was like 90% deaf, so when he did it, he bet $2 at a box of cigars with his team, and he didn't think it worked. He couldn't hear it. Luckily, he had an honest team, and they told him, no, Tom, it's working, and they patented it the same day. Okay? I'm not saying it's not an SR&ED project, but the problem with scientific uncertainty is, and you can look at it at Smithsonian, you can go and there's this one-page drawing of this device. He thought of it, say, 8 in the morning, and they patented it at 2 that afternoon. Right? So the project started at 8 a.m., say 3 guys. What, 20 man-hours maximum? It's not a big project. Most eureka breakthroughs, which is what people are famous for and they want to tell you about, because that's going to get them on the front of magazines, are completely irrelevant to the SR&D. Most SR&D is not earth-shaking, what they call paradigm shift inventions. Most are very small, infinitesimally small, incremental improvements. So we'll take the same developer, Thomas Edison, quote unquote, inventor of the light bulb. Again, I'd say he perfected the light bulb. But there was lots of light bulbs. There was a guy named Humphrey Davy who 70 years before the light bulb created something called an electric arc, which was the light bulb. Light bulbs weren't new. Light bulbs were being created by hundreds of people at that time. But Thomas Edison got the patent. And what he did here is he said, the problem with the existing light bulbs is they work, but they're not commercially viable. We need something with a high resistance, a filament with a high resistance and a high melting point, so it'll last a long time and not cost a lot of money. And Edison Power experimented with 3,000 different materials, figured out this one type of cotton thread was the best if they treat it somehow, and the rest went on. And this was before there was big material science catalogs that would they had a hypothesis, they gathered data, they did analysis, results and conclusions. It was the perfect scientific process. But they knew it could be done. They were just trying to make it commercially viable. So again, the difference between incremental improvements and eureka breakthroughs, scientific uncertainty and system uncertainty, is evidence. Most industrial R&D projects focus on system uncertainty. We know it could probably be done with unlimited time and effort. We just don't know the optimal path, configuration, system, architecture, and so forth. Okay, so we talk about Humphrey Davy in 1810, 70 years before the first official light bulb. There's actually 2 Canadians that created a light bulb before Thomas Edison, but he bought the rights off him, so I guess he's the inventor, right? Okay, so we'll wrap it up saying, okay, what kind of things can we use then at a very high level to look at projects? And one thing that I use is something called the key criteria summary. So instead of reading a 5-page project, which takes time, I want to have a quick snapshot where in 5 or 10 seconds I can say, this looks like a good project, or here's the problem areas I expect, and I'm going to focus exactly on those areas of the description. So I want to make sure we benchmark technology. I want to make sure we've got activities correlating to uncertainties or variables, and that we have conclusions cited, not just results. The why did something work, not what happened. Why do I think that happened?